This is the third video in the game-based physics video series to go to my intro to game-based computer programming class. And this one deals with forces of acceleration, frictional forces, and vehicle motion. And the first thing we have here is we have a simple movie clip that is named My Ship with lowercase my, capital SHIPP. And again, these tutorials were taken from chapter 12 in Beginning Flash Game Programming for Dummies, written by Andy Harris. Excellent book on simple codes to better understand game-based computer programming. And something about this movie clip, hopefully by now you understand through how to make animations and how to have different frames, how to label frames. So the first frame inside the movie clip, so we're inside the movie clip ship, and we have the label for frame 1 is thrust, and then for the label for frame 20 is still, and for frame 25 is left, and for frame 30 is right. And basically, if you look at this, right, this is our basic ship design here. Right, so we drew a little ship, and when we have a thruster on, we put these two little fire cones on the back of it. Right, and that's all it is. It has little changes in it, so it looks like a little fire is actually going on there. When there's still, there's nothing being thrusted anywhere. And we have left, we just have these two little blasts, one coming out of the nose cone and one coming off the side. So it'll spin to the left. It'll look like it rotates to the left. And to the right, we have the opposite. So it looks like it'll spin clockwise or to the right. So we have our wings, our flames. And that's all there really is in here. We have a little bit of code. So if I have our window, our actions, you'll see that what I have is I have a loop code going on here. So we have an enter frame event, and it runs the function thrust loop. And thrust loop just tells it to go to and play the label thrust. So when we run this, when we go to frame 1, it'll run automatically, and when it gets to frame 13, which it says right here, then it'll loop back to frame number 1, which is the thrust. And you'll see when we write our code, for the other things we're pressing the keys, we'll have a go to and stop for 20, 25, and 30, so that when it gets to those frames, it'll just go to and stop there at that frame. All the extra space in here is just to make it easier to read the actual codes that exist there. So let's go back to our main scene, the main time frame of our scene, and let's look at the action script that we have here. All right, so we're going to use our arrow keys that are located in the lower right corner of your keyboard. And we've talked about this. There's a video on how to add keyboard events, listeners. And what we have is we're just going to use 3 keys. We're going to use the up arrow to go forward, and then we're going to use the left and the right arrows to rotate to the left and to the right. We create these variables, and they're Boolean. They have 2 states, either true or false. Either you're pressing it or you're not pressing it, or you released it. And when you start the game, obviously there'll be nothing pressed, so it'll be false. So we start at false. That's the state it'll be in when we run the program. And then we add our numeric variables, our number of variables. And when we do the ship, my ship is the name of the movie clip. The dx is equals 0. The my ship dy is equal to 0. My ship speed is equal to 0. My ship direction is equal to 0. That means straight up and down. My ship go to and stop at the still frame. So it'll automatically go to and stop of the My Ship movie clip. Inside the My Ship movie clip, it'll go to and stop at the still frame, which is without the thrusters taking place. And then we have a new variable we're going to create, a number variable. We're going to call that, you can call it anything you want, but I'm going to call it thrust speed, and it starts at 0. So we have our keyboard events. So we want to add our key down listener events, and we have the function key press down like we've been using for all of these. So I'm just copy and pasting these from one program to the next. We have our stage add listener event, keyboard key up, and that's key pressed up. And then we have our check keys enter frame function to check our keys when we press on them. And then we're going to have a function that we're going to call ship move, where we're going to put our functions inside when we want the ship to move, and that's going to be an enter frame listener event also. We only have 3 keys, so we have our press down code 37. The left arrow is true when it's pressed down. The right arrow is true when it's pressed down. Code 39. Key code 38. Up arrow is true when it's pressed down. This is the same thing we've been doing for the other videos that we have motion due to our keyboard keys being pressed. Then we have our false for 37, 38, 39. All right, for our left arrow, right arrow, and our up arrow. If it's released or key pressed up is what we call the function, then they will all be false. All right. Now we're going to run. We had our ship move function, and now we're going to run our on enter frame ship move function. It's an event, an enter frame event, and we're going to have a my turn. We're going to turn the ship, and we're going to move the ship. And we saw that we've seen these functions used in previous videos, and it'll be discussed more in other videos that we're using to turn things or move them. All right, so we have our check keys. So what's going to happen is if the left arrow is pushed, our direction is going to be -10, and we're going to have our inside our My Ship movie clip, we're going to go to and stop at the left frame, which we just saw has the thrusters pushing it to the left. And then we have the My Ship direction. If it's less than 0, then you go all the way back to 350, so you continue to go in a circle over and over again. If the right arrow, then you add 10, or it turns to the right. And if the right arrow is pushed, then we will, inside the My Ship movie clip, we will go to and stop at the right labeled frame, the frame labeled right. And if the direction becomes greater than 360, then we go back to 10 and start over again. For the up arrow, we will have a thrust speed equal to 1. And our thrust speed is going to be an acceleration, a thrust acceleration. And we're going to use the movie clip inside the My Ship movie clip, where we go to and thrust the thrust loop. So that was frame 1, and then we had that little bit of code, so it looped over and over again to show the thrusters look like they're firing. Or else, if we have our thrust speed equal to 0, then we're going to have the My Ship go to and stop at the still frame. Okay? No acceleration will take place then. It'll stay at the speed it's going. So we have our turn function, and we have our My Ship, the rotation of the movie clip is equal to the My Ship direction that we just saw being added, subtracted from the right key and the left key when it's pressed down. And we have our degrees variable, right, as a number, and we have our My Ship direction -90, right? And then the radians is the degrees divided by pi, which is a math code, divided by 180. So pi is 3.14. You could use numbers instead of this, but pi gives you a more accurate representation than just putting in 3.14 or 3. Your variable thrust, dx, equals a number, thrust speed times the cosine radians, and your thrust dy, which is a number variable, is the thrust speed times the sine of the radians that we just determined in this formula. My ship dx is plus equals, so it adds the thrust dx for each frame, and your my ship dy adds the thrust dy for each frame as it plays through. And then the last bit of code we have here is the move. So the function move for the my ship movie clip is your x plus equals the my ship dot dx, and your my ship y plus equals the my ship dot dy, and this moves it in a direction. If my ship dot x is greater than the stage width, then you go back to 0. So x to 0. So if you go all the way to the right, it then appears back on the left. This is just like what we did in our intro to game-based programming, where we showed a ball wrapping around the screen. As it leaves one side, it enters the opposite side. And we see this with the code. Once again, it's the same code we've been using over and over again. So let's hit Control, Test Movie, and see. So we start. It says go to and stop at the still. Now if I press the up button, or let's go to the right. I'm going to press the right button, and it rotates to the right, and it's playing. It's going to and stopping on the right movie clip frame label. And if I press the left button, it's on the left movie clip frame label inside the My Ship movie clip. And if I press forward, it goes forward, and only when I press the key does it show the thrust, and it has a thrust speed. It continues to thrust. So I can stop it again, right? And then I could spin it in different areas. So you can go ahead and play with that. And that shows kind of we have a acceleration taking place when it's thrusting, but we have a constant speed when it's not thrusting. So acceleration only takes place, your thrust speed or your thrust acceleration only takes place when you push the up button. And then once you stop pushing the up button, this acceleration stops taking place, and you have a constant velocity, which is stays in the same direction with the same speed. Right? And if you're skilled, you can try and stop it. All right. So let's go on to our next one. Now the next one is a boat. So I got a it's labeled car, I know, but it's a boat, and it's going to simulate a boat in water. So I named this movie clip car. So even though it's a boat, I ran some of the old codes. I copied off the first physics video where we had a car scene in there, and you can see we have all the same code for entering our 4 keys, our up, down, left, and right keys. All Boolean variables all start in a false state, not being pressed. And then our car.speed, the movie clip car.speed, is equal to 0 at the beginning. Our direction is equal to 0. Our dx is 0. Our dy is 0. And then we have our variables. We're going to have the drag, which is a type of friction, 0.9. And we have the traction number is 0.5. And we have a thrust speed, just like we had in our spaceship. And then we have a drift dx and a drift dy instead of a thrust dx and a thrust dy. All these variables, the majority of them are 0, but our drag is 0.9 and our traction is 0.5. So we have to add our keys. So we have to have our check keys and our key pressed up and our key pressed down for our key up and our key down listener events, and our enter frame check keys listener event. And we have all the same codes for our function, key press down, true, 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 true for our left arrow, right arrow, up arrow, down arrow, and false, 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 false for our key press down, left arrow, right arrow, up arrow, down arrow. And then we have our car move, just like we had before, just with our My Ship spaceship move, ship move. So we have this move and turn, and we have our check keys function. which is the same. We have our car direction minus 10, plus 10 when the right arrow is pressed true. When the left arrow is pressed true, we have minus 10. If it's less than 0, we go back to 350. If it's greater than 360, we go back to 10. We have a thrust speed of 1 or a thrust speed of 0 when the up key is pressed. And we didn't have anything for the down key, so we could have had the down arrow left out there because we don't have anything taking place in our check keys function for the down arrow. So that was just a mistake. So I can go back here and I could say, all right, we didn't need this. Remember, I copy and paste these to save time, so we didn't need the down arrow. And when we did this with we didn't need a down arrow here. And we didn't need a down arrow here because we're not going to use the down arrow. File, save. We're not going to use that down arrow. We're just going to use, just like the spaceship, the up and to the right and to the left. All right, so now we have our turn function. This is where things get a little bit different. So here's our turn function right here. We have our car rotation equals car direction, just like it did before. Our degrees is the car direction minus 90, like it was before. Radians is still degrees times math pi, 3.14 divided by 180. And we have a variable speed this time, which is the square root of the dx times the dx plus the dy times the dy. And this is, of course, Pythagorean theorem, where c squared equals a squared plus b squared. So the square root of a squared plus b squared is equal to our speed, or a resultant speed. And that's what's being displayed here in this equation. And the drift dx is equal, which is a number variable that we called out in the introduction to this code, is the cosine of the radians, and the drift dy is the sine of the radians. The drift dx is multiplied by our speed variable, which is the resultant, and our drift dy is also multiplied by the speed variable. And our thrust dx is thrust speed times the cosine of radians, and the thrust dy is our thrust speed times the sine of radians. Our car dot dx plus equals the thrust dx, the car dot dy plus equals the thrust dy, and our car dot dx multiplied equals the car drag, and the car dot dy multiplied by the car drag. Okay, so remember, the equal means that you just add it to itself, add it to itself, add it to itself, or you multiply, multiply, multiply as each enter frame takes place. And then this last bit of code we have here is our function move car, and we have our car dot x is plus the drift x times the car traction, and which was 0.5, and we have the car dot y is the drift dy times the car traction. So we see up here our car traction is 0.5, our car drag was 0.9, and that those stay constant. They're constant number variables. We also have plus the car dot dx multiplied by 1 divided by the car traction, and our car plus the car dot dy multiplied by 1 divided by the car traction. If the car, and then the rest of this code is our wraparound code. If the car dot x is greater than stage width, it returns a 0. If the car dot x is less than 0, it goes to stage width. So if it goes to the left, it comes off the other side. All right, so this is the same code we just saw in the last one. So let's take a look at it. Control, test movie, flash. All right, so nothing happens. If I go to the right, it turns to the right. If I go to the left key, press the left key, it turns to the left. If I go forward, but unlike the spaceship, it goes faster and faster and faster, but then it has a friction. It has a drag to it in the water. So it'll come to a stop, right? So our spaceship was in a frictionless environment, and our boat is in a environment that has a fluid friction or a drag to it. So it comes to a stop. Alright, so now the next one is we're going to add a planet. Alright, so this is locked. So we have our spaceship, same clip inside, same code, but we're going to add a movie clip called a planet. And then what we're going to do is we are going to add a code. So our spaceship, this is all the same from our spaceship. We added, this is new, the planet gravity, right, variable. And we have a number of 1,000, right? This is all the same, right? This is all the same from the last one. Now, our ship move, we're going to add a new function called gravitate towards the planet. So our planet movie clip is named planet. We have gravitate on there. And if we look in here, we'll see that our check keys are all the same. So this is all the same as we had in the original space clip. All right, we have rotation, degrees, number. Our turn is all the same that we had. We have our function for this is all the same. So we have a new function at the bottom, and this is our gravitate towards the planet. And we have our temporary dx, which is a number variable, is the my ship movie clip, the movie clip from my ship, x position minus the planet x position. So what we have here is we're gonna see that we has the distance between this is how much of an attraction the object has between it. Right? We have our c squared equals a squared plus b squared code again, where we have the square root temp dx times temp dx plus temp dy times temp dy. All right, and that's our temporary distance. And then we have our temp dx divided by temp distance, and our temp dy divided by the temporary distance. And then the temporary dx is multiplied by the planet gravity, which is 1,000, divided by the temp distance times the temp distance, and we have our temp dy is the same, planet gravity divided by temp distance times temp distance. We have a temporary dx multiplied by -1, a temporary dy multiplied by -1, and we have the my ship dx is plus equals the temp dx, or my ship.dy is the addition of the temp dy. That's all the code we have. And we have control test movie in Flash, and you'll see that the ship is attracted to it and it gets accelerated as it goes through it. So you can see that there is like a planetary gravitational force that attracts the ship. And then you could try and see if you can get it in an orbit around this planet by changing the numbers. So if you're lucky, you can or if you take time, you can see what it takes to get it to orbit around the planet. And then we have the same thing here. We have three. So we have a blue planet, a green planet, and a red planet. And we look at our ActionScript code, and we'll see that this is all the same. Our planet gravitates all the same. Our keys right here are all the same. But what we're going to have is we're going to have a gravitate for the green planet, for the blue planet, and for the red planet. Everything else is going to be the same. When we get down here, this is all the same. All this is the same. But what we have is we call it out as our planet. So this actually stays the same, but our gravitate function is assigned to these three movie clips in our enter frame event, the ship move. So now when we can add these, control test movie, you can see that it is attracted to the different planets. And the closer it gets to one, the more it comes out the other one. And then you can once again try to get it to orbit. It's going too fast. It got accelerated too fast there. So you can have some fun with that. You can add as many planets as you want to have a different levels. This last video is still off Andy Harris's book, and what we have here is a simple lunar lander game, movie clip, lander, and it's just a little drawing, circle, rectangle, turned into a movie clip with the instant name lander, and then this is just a rectangle with the instant name platform. Alright, so let's take a look at our action script. And what we have here is we have three keys we're going to use from our keyboard. We're going to use the left arrow, right arrow, up arrow. So we put in our Boolean variables, all start at false. And then we have our lander dx variable is going to be 0. The lander.dy variable is going to be 0. And we're going to have gravity number 0.2. And then we're also going to have a variable called the lander on the ground, and that's going to be a true or false Boolean variable, and it's going to start false because it's not on there. We're going to put in our check keys and our key press down, our key up, and we're going to have a function called lander thrust. So we have our key codes 37, 39, and 38 for our right, left, and up arrows. All true for the key down, key press down function. All false for the key pressed up function. And then we're going to have our check keys, and our check keys are going to be that if we press down on the up arrow, making that a true, then our lander on ground is equal false, and the lander.dy is minus 0.5 for each frame that takes place. If we have the left arrow, then the dx is going to be minus 0.1. If we have the right arrow, then our dx is going to be plus 1 for our lander movie clip. All right, so if we put the up arrow, then we're going to the dy is going to move up, and if we have the left arrow, it'll move to the left, and to the right arrow, positive to the right. So in our lander thrust, we have our move function for the lander, and then check landing. All right, these are events function. And so our move is if the lander on ground is equal to false, then we have our plus equals gravity. All right, so our lander x is the lander dx, and the lander y is plus the lander.dy. If the lander.y is stage height, then it'll go all the way to the top. So in this one, instead of crashing, if the lander falls all the way to the stage height down at the bottom, then it'll end up going all the way back to the top, and you can try again. All right, you can change that code any way you wanted to. The last part is our check landing, and we're going to do a hit test. All right, so if the lander movie clip hits the platform movie clip, then it'll be true if they touch each other. So that's a hit test on the object. And if this is true, then your lander.dy is greater than 0. If the lander.dy is less than 2, and if the lander.dx is greater than -1, and if the lander.dx is less than 1, then the lander.dx will equal 0, and the lander.dy will equal 0, and then we'll have the lander on the ground will be a true event, or a true Boolean event. So let's go ahead and control test movie, and you'll see how these codes are working. So it falls because of gravity, so I push the up arrow, and you can see it goes up. If I push the right arrow, it moves to the right. I push the left arrow, it moves to the left. I push the up arrow. So gravity is always pulling it down. And if I go up, I don't have a wraparound for the up. But if I let it drop all the way down to the bottom, then you'll see that it comes up from the top again. Okay? So in order, I don't have this to crash, but I have a hit test. It has to have a speed. So it goes right through there. See that? So we need the dy to be greater than 0, but less than 2. All right, so we'll come over here, and if we can get this, and it can't be moving to the side, because if it moves to the side, even if I'm moving slow, so I'll keep this going. If it's moving to the side greater than -1, oh, uh-oh. I might have just lost it. So, oh, there it is. Okay, so I can't go. It doesn't wrap around. It only wraps from the bottom up again. So I don't have the wrap around from the left to the right stage width to 0x horizontal. So I have to have this moving very slow, and then you can land it like that. Okay. So if I move too fast, it falls through, and if I move to the right too much, it falls through too. So even though it's slow, if it's moving to the right or to the left greater than 1, it will fall through the platform. So it has to be between 1 and -1 to the right and left. You can see you can stop it right in the middle too. And it has to be less than a speed of 2 to land and stop on it for the Y going up and down. And that is our lunar lander game. You could create a whole bunch of things to put points on the side if you wanted to. Use the scripts that were in the Pong game to do stuff like that.